I have a problem. I'm still not sure how, but I've forgotten all of mathematics. From the deep intricacies of set theory to the banal calculation of matrix addition. And so I've embarked on a journey to rebuild all of mathematics from scratch. I figured out a lot of different things last time, which left me with a lot of things I could explore today. The most important is I've come up with a system for representing large numbers using symbols or numerals, rather than long, cumbersome number words, and in the process, I figured out that I could count numbers in the same way that I can count objects. I also came up with the idea of a potential number to represent nothing, which I'm calling 0. But I'm still not completely convinced that I can treat 0 as a number without breaking anything. Maybe that's a good place to start today. I've noticed something about every number I've come up with so far. See, 2 is 1 and 1, 3 is 1 and 1 and 1, and so on. Each of them is built out of a sequence of 1s. This doesn't work for 0, though, since there's no way to make nothing out of a bunch of 1s. Is it okay to add a number outside of this framework? I think I have to come to better grips with what exactly numbers are. Fundamentally, this system I've built is just a way to model counting things. If I have 1 apple and 1 apple, I have 2 apples, just as 1 and 1 is 2. It's immediately useful for 2 reasons. Firstly, it makes talking and thinking about how many apples I have much simpler. 5 apples is much easier to talk and think about than an apple and an apple and an apple and an apple and an apple. Secondly, it makes it easier to track things in complicated systems. If I have 2 boxes of 13 apples, a box of 12 apples, and a box of 7 apples, I can say that 2 13s is 26, and that 26 and 12 is 38, and that 38 and 7 is 45, so I have 45 apples. A lot simpler than saying I have a box of an apple and an apple and an apple and... you know what, I'm not even going to try to say all that. Even if it doesn't seem to fit in on the face of it, I should be able to introduce a new number, 0, as long as it doesn't interfere with either of these functions. The idea of 0 is that it should represent nothing. Just considering apples again, I can say 0 apples is no apples. 0 apples and 1 apple, well, that's just going to be 1 apple, of course. 0 apples and 2 apples would be 2 apples, and so on. There's not any inconsistencies here. 0 apples and 0 apples, well, nothing and nothing is just nothing. So 0 apples and 0 apples is still 0 apples. No problems so far. What if I start including boxes? A box of 0 apples, just a box with no apples in it. 3 boxes of 0 apples, 5 boxes of 0 apples, nothing unusual here. 0 boxes of 5 apples. Well, it seems like that should be 0 apples again. Nothing's causing any problems, but I do feel a bit uncomfortable. If I have 5 boxes of 0 apples, then it's simple. I have 5 zeros, and 0 and 0 and 0 and 0 and 0 is all still 0. But if I have 0 boxes of 5 apples, I have just nothing. Honestly, I'm not even sure how to tell if there's a problem here. I think I need to spend some time thinking about numbers, not in terms of things like apples or lumps of clay, but on their own terms, as things that can be counted and combined, whether or not they're being used to count anything at all. This is a bit nerve-wracking to do. The only reason these numbers are useful at all is because I can use them to count things, and if I stop thinking about them just as a way to count things, I might accidentally do something with them that makes counting things with them not work anymore. But on the other hand, I might also come to a deeper understanding of how they work, or even come up with new applications for them, making them more useful than before. Let's start with the number 1. As I've already noted, there's something special about 1. All of the other numbers, except maybe 0, can be built by combining a lot of 1s and other 1s. Again, 2 means 1 and 1, 3 means 1 and 1 and 1, and so on. But I think I can think about this all in a slightly different way. I could just as easily say that 2 is 1 and 1, 3 is 2 and 1, 4 is 3 and 1, and so on. Then I can say that every number, except maybe 0 again, is 1 and 1 some number of times. 2 is 1 and 1 one time. 3 is 1 and 1 two times, and so on. If I think about it this way, then it's easy to see that for each number, there's a next number, that number and 1, and for all of the numbers except 1, there's also a previous number. Or is that right? If I think about the numbers this way, then there's a place for 0 after all. 0 and 1 is 1, so 0 would be the number previous to 1. Does this alternate definition change anything else I've done so far? Thinking about a number and another number, so far I've always thought of it in terms of having some number of something and another number of something. But if I'm thinking just in terms of numbers without counting anything, how could I define what a number and another number means? I know what and 1 means. A number and 1 is the next number. But what about and 2? I know that 0 and 2 is 2, 1 and 2 should be 3, 2 and 2 should be 4. I got all of this from counting things, so I can't really use them for a definition, but they do still all have to be true for numbers to still be useful for counting things. If I come up with a meaning for a number and a number that doesn't keep these things true, then numbers won't work anymore. Actually, what if I turn that thought around? I know that there has to exist a meaning for a number and a number that lets numbers work for counting things, because even without knowing exactly what it is, I've been using it all along. I can try different meanings until I find one that works. If I find one that doesn't mean numbers are broken, it just means I need to keep trying. And who knows? Maybe I'll find a meaning which isn't useful for counting things, but that's useful for something else. This is a very freeing thought, though I still would prefer to have the right meaning for the task at hand before exploring too far off the rails. 0 and 2 is 2. I'm not sure what to do with that for now, but looking at 1 and 2, well, I want it to be the case that a number and another number is the same thing as another number and a number. That's how it works for counting real things, so I know that I can do that. So now I can say that 1 and 2 is the same thing as 2 and 1, which I know is 3. What about 2 and 2? Well, 2 and 2 is 2 and 1 and 1. And I know that 2 and 1 is 3, so this is the same thing as 3 and 1, which is 4. And now I'm seeing a pattern emerge. Let's look at something a little more complicated, say 6 and 5. Well, 5 is 4 and 1, so 6 and 5 is 6 and 4 and 1. So if I know what 6 and 4 is, then I know what 6 and 5 is. None of this really depends on the 6 or the 5 specifically being a 6 or a 5. It would be easier to talk about this if I had a way to refer to numbers generically without having to specify what exactly they are. Why not? Let's say I have two numbers, and they are proper numbers with proper number names, but I don't care which ones they are. They could just as easily be 5 and 7, or 26 and 704, or 10 and 10 billion. But I'm going to give the numbers labels A and B to keep them distinct from each other and just to make talking about them easier. Although, let's say one thing about them. B isn't 0, because that way, I know that there's another number, I'll call it C, that comes before B. That is, C and 1 is B. Again, I don't know what C is, but I know that it exists because B isn't 0, and every number except 0 has a number that comes before it. If I know what A and C is, then I know that A and B is just A and C and 1. And so it's just the next number after A and C. If I don't know what A and C is, and C also isn't 0, I can just do the same thing. I can take the number before C and label it D, and then A and C is the next number after A and D. And I can keep on doing this. Eventually, even if I don't know what A and any other number is to start with, I'll get to A and 1, which is the next number after A. And once I know what A and 1 is, I know what A and 2 is, and what A and 3 is, all the way up to A and C, and then A and B. And there's one last thing to mention. I was assuming that B wasn't 0, but of course, if it is 0, I already know what I want A and B to be. Just A. Putting all of this together, for any two numbers, A and B is, maybe I should be using a different word for this than and. If I keep talking about things like this, it's just going to get more confusing, isn't it? I'll just say, I don't know, plus. So then for any two numbers, A and B, A plus B is A if B is 0, and it's the number after A plus the number before B if B isn't 0. While I'm coming up with new words, let's come up with a word for what I'm doing here. Let's say that this process of combining numbers is called addition, and that combining two numbers like this is adding them. If some number A plus some number B is some number C, then let's say that C is the sum of A and B. So I can say that 3 and 5, that is 3 plus 5, is 8. And I can also write that out like this. This feels like good progress. Let's see what else I can do. How about for counting numbers? I've already thought about things like 2 3s or 3 5s. Can I do something with this more abstract system to get a better idea of what's going on here? Well, 1 of a number should just be that number, and 0 of a number should be 0. 2 of a number is 1 of that number and another 1 of that number, so just that number plus itself. 3 of that number would be 1 of that number plus 1 of that number plus 1 of that number. I feel like I can do something here like I did with my definition for plus. So if I have some number A and some number B, what can I say about the number that I get out? Well, if A is 0 or if B is 0, then I can say I just get 0. If A is 1, then I just get B, and if B is 1, then I just get A. And if A and B both aren't 0 and aren't 1, well then, as before, I can say there's a number that's before A, and label it C. If I know what number is CB's, then AB's, which is C plus 1 B's, should just be that number and another B, or rather, that number plus B. This seems like it'd work how I want it to, and I can actually simplify my rules a little bit. The last rule doesn't care if A or B is 1, or if B is 0, it just needs A not to be 0, and it still gives me the results that I want in those cases. Before I put all of this together, let's come up with some new words like I did with plus. If I have 5 4s or 12 4s or 57 4s, I just end up with more and more 4s, like the 4s are multiplying, so let's call the process multiplication. For the result, I'll just call it the product of A and B. As for an equivalent to plus, well, come to think of it, what I'm doing when I say I have 5 2's with my definition is basically adding 2 to 0 5 times. I'll say that the number you get when you have 5 2's is 5 times 2. Putting everything I've come up with together, I can say the following about numbers. There is a number 0. There is another number 1, and another 2, and so on, with 1 being the number after 0, 2 being the number after 1, and so on. Each number has exactly one number after it, If I have any two numbers, a and b, I can say that a plus b is another number, which I can call the sum of a and b, and a times b is another number, which I call the product of a and b. To find the sum of a and b, I can use these two rules. To find the product of a and b, I can use these two rules. So now I have these three rules that define what numbers are, along with 2 to define addition and 2 to define multiplication. It's kind of incredible to think that all this work I've done can be summarized so succinctly. Everything I've figured out about numbers and counting follows from these 7 simple rules. There's still a lot more to be done, but I'm proud of what I've managed to build so far.